In this video, we're going to specifically only look at standard deviation. So, what is standard deviation? Well, it shows you how the data, and this is where it gets its name, deviates. Oh, I gotta change the marker. So, deviates from the mean. So when we have a low standard deviation, that tells us that the data tends to be quite close to the mean. So that means our range is quite small, therefore all the numbers are close to the mean. If we have a high standard deviation, that indicates that the data is more spread out and therefore further away from the mean. So I thought I'd give you guys a visual of such two things, of small standard deviation and large. So you can see in our first image, okay, where the mean is, whoops, didn't mean to do that, where the mean is right in the middle, you can see that all the numbers are quite close to that number. Whereas in a large standard deviation, you've got more of a spread out of your data. Okay, and so take a minute and find some space in your notes and just do a quick sketch of what a small standard deviation looks like and a large. So let's look at how do we calculate this by hand. It looks intimidating, but I swear it's not bad, okay? And it's a little time consuming, but not difficult. So what we'll do, well, first of all, it says Caleb tracked his calorie intake for a week. Find and interpret the standard deviation of his calorie intake. So we've got, 1,950, 2,000, 2,100, and so forth. What we want to do first, which is why it says over here, step 1, we just want to find the mean. We know how to do that. So in my calculator, I'm going to add all these up. So 1,950 plus 2,000 plus 2,100 plus 2,000 plus 1,900 plus 2,100 plus 2,000. I'll add those all up and then divide by 1, 2, 3, 4, 5, 6, 7 numbers. I get that my mean is 2,007. Now, in regards to when we're finding standard deviation, we use the symbol that's the X with a line above it. That means my mean. Okay? So in my chart below, I'm going to just write 2007 throughout that entire column. 2007, 2007. Once I've done that, in my next column, all I'm going to do is subtract these two bits of information. So I'm going to take my first data point, and I'm going to subtract it from my mean. So 1,900 minus 2007. And that gives me 107. I'll do 2007, minus 2007. Look at that. That's not even difficult. I know it's 0. And I happen to do that a couple more times. Whoops. Wait a minute. Oh, I'm a dingus. Let's try that again. I was looking in the wrong direction. Whoops. I meant to say 1,950 minus 2007. Okay, there we go. So that gives me 57. Then I'll do 2,000 minus 2007. That's going to give me, it'll give me -7. That's okay. Then I'll do, again, 2,000 minus 2007. And then I'll get -7 again. So you guys can kind of see where this is simple, just maybe a little time consuming. Okay, so then 2,100 minus 2007. Okay, that's going to give me -93. And then I'll do it one more time, knowing that it'll give me -93. So in my next column, all I'm going to do is I'm going to square these values. Now notice how it has parentheses. I cannot stress this enough that when you plug in things that you're squaring, especially in negative, that you use parentheses, okay? So 107, when I square it, gives me 11,449. I'll square 57, that'll give me 3,249. Now I know that 7 squared is positive 49. And then 93 squared is 8,649. So I did all of this. Okay, we're organizing it all this way because now we're going to add all of this up. That's going to go in this box right here. And I kind of wrote into that box with my circle there, so I'm just going to delete it. So when I add up all of those numbers, that gives me 32,143. Now to find standard deviation, all I do is I'm going to square root this number that I just calculated over here, so that 32,143, and I'm going to divide it by the number of data points that I have. And that number is 7. So if you want to, in this box here, you can always fill this out by just counting up all those data points, and it's 7. So basically what we're doing is we're square rooting the ratio of my square of the differences all over the number of data points I have. So now that'll give me approximately 67.8. That's a pretty large standard deviation. So knowing that tells me, okay, all of my data points are quite far away or spread out in comparison to the mean. So why don't you guys try this one on your own? So what does it say? It says, Ed surveys his classmates to find out how many electronic gadgets each person has in their home. Find and interpret the standard deviation of the data set. So remember, you want to first find the mean. Okay, find your average. All right, and then I want you to write that down here. Then you'll find the difference between each one and then square it. From there, you'll add those numbers up down here and here and square root that ratio. Okay, so this may take you some time. So take your time. Okay, and then check back in the video to check your answers with mine. Okay, I have a lot thrown at you right now. So your mean should have been calculated as 9. So I wrote 9 in my mean column. Then I found the difference of every single point, every single data point I should say, and then I squared each value. Notice how all my squared values are positive. It is impossible for any of them to not be positive. Then I added up all of that down here to get 52, and I have a total of 52 data points, and I square root that ratio. And so I find that my standard deviation is 1.9. That's very small in comparison to that first example we saw. So that tells me that all of my points are very close to the mean, and that makes sense. I mean, look, I've got the lowest I have is 5 and the highest I have is 9. That's very close to 9. That makes sense that I would have a low standard deviation.